Sir, good morning, sir. My name is G. Kiran Kumar, and my roll number is 21951870, and I am from ECE section. And my topic is biodegradable polymers. Introduction. A polymer is a substance or material consisting of very large molecules or macromolecules composed of many repeating subunits. Due to their broad spectrum of properties, both synthetic and natural polymers play essential and ubiquitous roles in everyday life. Polymers make up many of materials in living organisms, including, for example, protein, cellulose, and nucleic acid. Moreover, they constitute the basis of such minerals as diamond, quartz, and feldspar, and such man-made materials as concentrate, glass, paper, plastic, and robots. Characteristics of ideal polymer should be insect and compatible with the environment, should be non-toxic, should be easily administered, should be easily and inexpensive in fabricate, should have good mechanical strength. These are the characteristics of ideal polymer, and we have to include this polymer and we have to follow this. Classification of polymers. Based on biodegradability, polymers are classified as two types. First one, biodegradable polymers. For example, collagen, glycolic acid, etc. These are the biodegradable examples. Second one is non-biodegradable polymers. Polyvinyl chloride, polyethylene. These are the non-biodegradable polymers example. Let us see what are biodegradable polymers. Biodegradable polymers are defined as polymers comprised of monomers linked to one another through frictional groups and have unstable links in the backbone. They are broken down into biologically acceptable molecules that are metabolized and removed from the body via normal metabolic pathways. Microorganisms destroy biodegradable polymers in suitable amount of time, ensuring that biodegradable polymers and their degraded products have a no environment impact. Enzyme catalyzed process break these polymers down into little segments, and microorganisms manufacture these enzymes. Let us know something about biodegradable polymers. Biopro polyhydroxybutyrate hydroxyvalerate, polycarboxylatone, polyacetic acids, polyglycolic acids, polydioxide. Let us see what is PHBHV. It is a type of biopolymer. Its molecular formula is C27H42O12. Monomer weight 558.62 AMU. It's a 3 hydrobutyric acid and 3 hydroponic acid copolymer with ester links joining the monomer units. Properties of PHBV. What? Let us see properties of PHBV. Water insoluble and relatively resistant to hydraulic degradation. Good oxygen permeability. Good ultraviolet resistance but poor resistance to acids and bases. Soluble in chloroform and other chlorinated hydrocarbons. Biocompatible and hence it suitable for medical applications. Melting point is 175 Celsius and glass transformation temperature is 2 degrees Celsius. Tensile strength is 40 MP, a close to polymer polypropylene. It is a non-toxic, less sticky when melted, making it a potentially good material for clothing in future. Polycaprolactone. Polycaprolactone (PCL) is a biodegradable polyester with a low melting point of around 60 degrees Celsius and a glass transformation temperature of about minus 60 degrees Celsius. The most common use of polycaprolactone is in the production of specialty polyurethanes. Polycaprolactones impact good resistance to water, oil, solvent, and chlorine to the polymer producing. Uses of polycaprolactone. The most common use of polycaprolactone is in the manufacture of specialty polyurethanes. Polycaprolactones impact good water, oil, solvent, and chlorine resistance in the polyurethane produced. This polymer is often used as an additive for designs to improve their processing characteristics and their end-use properties. Being compatible with a range of other materials, PCL can be mixed with scratch to lower its cost and increase biodegradability, or it can be added as polymer plasticizer to PVC. Properties of biodegradable polymers. Let us see some of properties. Biodegradable polymers can maintain strong mechanical integrity until they are degraded. Degradation usually starts at the end groups because biodegradable polymers have exceptionally strong carbon backbone and are difficult to crack. It is a non-toxic biodegradable polymers. Biodegradable polymer degradation rates can be controlled. Biodegradable polymers also lack crystallinity, which inhibits access to end groups. Hydrophilic polymers are biodegradable polymers. Facts of affecting biodegradation of polymers. Monofocal factors: shape and size, variation of diffusion coefficient and mechanical stress. Chemical factors: chemical structure and composition, pressure of iconic, ionic group and configuration structure, molecular weight and presence of low molecular weight compound. Physical factors: processing condition, slicerization process. Advantages of biodegradable polymers: localization, delivery of drug, sustained delivery of drug, stabilization of drug, decrease in the dosing frequency, reduced side effects, improved patient compliance, controllable degradation rate. Disadvantages of biodegradable polymers: to contain potentially toxic materials, landfills are designed to be moisture free and airtight. Biodegradation is often slowed by these aerobic conditions, which helps to prevent harmful compounds from being released from landfills. Second point is biodegradable polymers are excessively expensive to produce. They aren't easy to come by. Commingled plastic recycling is not a good fit for biodegradable polymers. Applications of biodegradable polymers. Polymer system of gene therapy. Biodegradable polymers for ocular tissue engineering, vascular, orthopedic, skin adhesive and surgical gloves. Biodegradable drug system for therapeutic agents such as anti-tumor, antiseptic agent, anti-inflammatory agents. Polymeric materials are used in and on soil to improve aeration and promote plant growth and health. Many biomaterials, especially heart valve replaces the blood vessels, are made up of polymers like dragon, terpene, and polyurethane. Conclusion: numerous synthetic biodegradable polymers are available and still being developed for sustained and targeted drug delivery applications. Biodegradable polymers have proven their potential for the development of new advanced and effective DDSN capable of delivering a wide range of bioactive materials. However, only few have entered the market since many drug faces a problem of sensitivity to hot, shear forces and interaction between polymers. These polymers can be come over by fully understanding the degradation mechanism to adjust the release profile. Thank you, sir.